Okay, we are starting a new unit. I'm kind of excited about this unit because it's definitely a step in the direction that will kind of remind you of what calculus was like in the first year, and it won't take too long before we start to incorporate some of those pieces with vectors and 3 dimensions. Uh, those pieces will get involved soon enough. So the topic is generally called functions of several variables. So let me just go back and highlight some information. And the first thing is, what was a function? And there's lots of ways of describing a function. May I suggest to you that the visual, called the vertical line test, is not going to be your best one when we increase number of variables. In fact, I would suggest you may not use it at all, or very seldomly, depending on the situation. But the basic concept of a function is where you put something in, you only have one output that comes out of it. When you put something in, you only have one output that comes out. So the concept we started with, our old version of it was you have y equals f of x. So, you have your input x and your output y. But I'm going to just put quotes on those because they don't have to be x and y. Only math teachers do that. In the real world, there's other variables used, probably not x and y. Recently, we saw what was called a vector valued function. And what went into this function, the input was t. You could think of t as time, but it doesn't have to be time. And then the output was a vector. Vectors give us direction and magnitude, and we looked at acceleration besides velocity. So what we're doing now is we're saying that these two functions had a single input. We are going to look for functions where there's more than one input. So you're going to see functions that might look like this. F of xy or f of xyz. And there could be more variables input. Again, only in the algebra classroom or maybe this calculus classroom, when you're studying the theory, would you use these letters alone. The real life applications for these are vast, and if you're a computer programmer, you're going to look at it one way, and if you're somebody doing marketing, you're going to look at it a completely different way. You might not ever use function notation. So let's do a little spotlighting some of these little details so that you can better understand them. So I'm going to just show you these two things at the same time so you can see. Here's an algebra version, but I'm interested in what is it for. And so think of this. If you put your, we'll call this the input, your name, and the day of the week, the output might be your work schedule for that day. It takes two things for the boss to know what to do. The boss needs to know who is it, what day of the week are we talking about. Okay, I can tell you your schedule if I know those two things. So there's two inputs here and there's one output. We could do latitude and longitude. as the input, and the output could be the name of the nearest city or town. And we know that there are some undefined values for that function, because if you're in the middle of the Atlantic or Pacific Oceans, or the China Sea or the Indian Ocean, there might not be a city anywhere, be undefined. We could do 3 dimensions, latitude, longitude, and we could do altitude. And then the output could be the temperature. I want you thinking that these are highly useful notations that we're going to be using and studying. But again, when the algebra teacher gets a hold of it, it kind of sterilizes all the interesting stuff out of it for a little while. But if your long-term goal is to be able to apply it, it makes it a little bit easier to think, oh, we have to study how the parts in the theory work before I can properly apply things later on. And you know you're not going to need every tool. My job is to show you a huge set of tools, and then you'll use the ones that you need. And if you're an engineer, you might need it for one project, but you won't need it for the next project. But the next project, you'll need other tools. So here we go. A little teaser at the end here. If I were to do the very basic concept, so for instance, what is f of 2 negative 3? This would be a substitution. 3 times 2 minus 5 times negative 3, 15 and 6. That would be 21. So we started with 2 pieces of information that went in, and we got a single value out, single value. But if I were to reverse the order of these 2 numbers, now x is negative 3 and y is positive 2, negative 9, that's negative 19. Clearly we get a different output out of this function if we switch the order. These problems here, you might not be allowed to switch the order. You can't call me Tuesday and the day of the week Mr. Math Professor. There's certain things that you're allowed to call these things. We call that domain. Come around for another video or two. We'll get to domain eventually. So the last thing I'm going to do in this introduction is ask the question, well, what is the f of xy? Excuse me here. What is the f of xy? And so I want to remind you that when we had only f of x, we often nicknamed this y equals. The output was a y value. So what do you think we should call the output for f of x and y combined? What do you think we should call that output? Well, it turns out that they call it z if you don't call it by the function notation. We could think of this as z, and I'm talking about the z that's the same z as in our x and y and z axes. We could call it that. And then finally we could say, well, what if there were 3 variables that went in? What would we call that? Our textbook calls it w. I'm just going to put a little smiley face here. If you're wondering if we're going to have to graph this one, the answer is no. But I will tell you that it's certainly something that is possible to study. Again, don't think of the 4th dimension as time necessarily. It's really easy to see here. If we have latitude, longitude, and altitude, temperature could be a great fourth variable, or air quality, or pick your other variable to measure. You can measure something at a location and call it another input. So this is just to get us started, but now we need to get down and start to do something with these functions. We're not quite going to hit calculus yet. We're going to have a few videos before we get into anything calculus related. But we're going to study some basics of functions that have more than one variable as an input. All right? Until next time.